last years I have been quite often here in Morocco for different things. We work together mainly with IRSEC'17 to install the PV test facility in Ben Guilhem, initiated different projects here. I also was here last April with our minister Gabriel at the time when the contract was signed for the Siemens wind blade factory, which is now running here in Tangier, so it's quite impressive to see the development. Before I will start with this quite technical issue of the soiling issue of photovoltaic modules in desert areas, let me give you a quick overview of the Anhalt University. So that's the new organization I'm now working with, and then because it is the first talk of the conference, I also give you a short introduction and motivation for investigations in the PV area. So Anhalt University is a university with 8,000 students, bachelor and masters, 7 departments. Actually, it is the university in Germany with the highest share of international students. We have 2,500 students from 108 countries. Also a university which is very strongly focused on entrepreneurship. During the last 7 or 8 years, there were 80 spin-offs from the university. Quite innovative, high amount of R&D at the university, and this summer it was selected among 29 other universities in Germany as innovative university. That's a program in Germany where German government will spend $500 million in the next years to support R&D and also transfer from the universities to industry. There is PV activities also at the university. As mentioned before, I was responsible for the Fraunhofer Center for Photovoltaics, Silicon Photovoltaics. We have 3 professorships in photovoltaics at the university. You know, I currently do not spend so much time in R&D, but Professor Bernhard and my successor at Fraunhofer CSB will be again a joint professorship between the university and Fraunhofer, and there will be an announcement during the next days who it will be. We have a photovoltaic master program, completely international program. It's an English program. So currently no students from Morocco in that program. We have something like 40 students from Morocco at the university. And this year we had nearly 100 people applied for that program, and we could enroll roughly 20. Okay, so that's quite a short overview about the university, motivation for research in photovoltaics, and then also the topic of the soiling issue. Let's check if that's working. Yeah. So, going back to the climate conference in Paris in 2015, the governments agreed that the global warming must not exceed 2 degrees Celsius. If possible, it should stay below 1.5. In the meantime, 175 countries around the world have signed that contract. One big country just decided to leave that cooperation, but all the other countries also agreed a few weeks ago in Germany to continue, and they also specified next steps. So from a scientific point of view, is a question, what does it mean? And there are a lot of simulations from scientists. If you want to reach that goal to stay below 2 degrees Celsius, and that's those blue curves over here, then you see there's a certain time, and it's roughly 2050. And in order to fulfill that goals to stay below the 2 degrees Celsius, that means no CO2 emission. No CO2 emission, and that's the result of that what was agreed in 2015 in Paris. Most people have not realized what that really means, because if you're talking about no CO2 emission, that means 100% renewable energies by 2050, and that's quite a big challenge. One technology which can reach that goal is photovoltaic industry. And the photovoltaic industry really went through a dramatic change during the last years, especially from the levelized cost of energy. If you look on that graph from Irena, you see the development of the energy price, so the levelized cost of energy over the last years. You see that it went down by nearly 100% over the last years, and the last big auctions, they were below 3 cents per kilowatt hour. It was impossible to think about that 4 or 5 years ago. And if you compare that with levelized cost, and it's analysis from the Energy Industry Association of the United States from beginning of this year. So this box shows the levelized cost of traditional energy sources like gas, coal, even nuclear. And you see that in some countries around the world, and especially sunny countries, also Morocco includes to that countries, the levelized cost of energy from PV is already now cheaper than the levelized cost of conventional energy sources. If we're looking on the PV market from the last years, we saw a dramatic growth. Last year we had an installation of 75 gigawatts of photovoltaic modules around the world, and so the slide is cut on the right side, so you do not see the predictions for the next years, but so you have to believe me that this prediction from Bloomberg says that this will increase over the last years. The difference, and that's just to show on or to compare 2017, for instance, with 2011 or 2012. So 2011 or 2012, 70 to 80% of all PV systems were installed in Europe. If you look on last year, it was something like 10%. So the market, the distribution of PV modules in the world dramatically changed. And also a very important thing is, I mean, last year China was by far the largest installer of PV modules. Nearly 35 gigawatts of PV modules were installed in China. So that's the entire installation of PV modules which we have in Germany. They were installed in 1 year in China. But the important thing is that part here, that's the rest of the world. And this is or will be the largest market for PV modules in the next years. And the rest of the world means we have installations in completely new climate regions, and we have challenges from reliability of modules. And that's what the scientific part of this talk will be about. And if we were talking about reliability of PV modules, there are a lot of things which you have to consider. So the one which I will speak about in the next minutes, soiling, is a very specific thing which is relevant for desert areas and also arid environments. And we had started with that investigation in the end of 2015. Initially it was started together with Ahmed NOE in a cooperation with the Kerry in Qatar, and in the meantime we have involved also a lot of other areas in the world. So yeah, so on some of the slides, so the right part is missing, but I hope I can explain that. So what you see on the diagram is the daily loss of power of a PV module in different environments. And you see that in some really harsh environments, like Kuwait in that example, you have a loss of the power per day by 1%. So if you're talking or thinking about that, your profit will be in the area of 5 to 6%. To loss every day 1%, there is no business with that. So the question is, so what's the reason for that soiling? It's the dust which is airborne. We can hardly influence that, but we have to understand that and also understand it for different reasons, different regions. And what people currently try to do is to optimize cleaning technologies and they also work on anti-soiling coatings. But what people do right now is they try different approaches, but they do not have a good understanding of the basic scientific reasons why those particles stick on a surface. And if you do not understand why they stick, it's not a good idea to optimize a coating. So in the first step, you have to understand the fundamentals, and then you can work on the optimization. And that's what this scientific investigation is about, to understand on the microstructural level the sticking behavior of dust particles on glass surfaces, and then to optimize that. Okay, so that's just an example without going into details. This is here from Morocco. That's different modules, but if you just look on the first part of that curve, that shows the decrease of the current in that case, but also the power over a certain period. And you see that in that test facility in Ben Guia, close to Marrakesh, the modules lose roughly 10% of their initial power after 1 month if you do not clean modules. So, and as shown before, there are some areas in the world where this decrease is even larger. So we started an investigation where we collected dust samples from different places in the world. So all those stars here are the locations in the world. So in Australia, it's in Qatar, Jordan, Algeria, Morocco, Spain, Chile, and United States. So we delivered test samples, glass samples, and also coated samples to those facilities. They were exposed to the local climate by different time periods between 1 day and 28 days. In addition to those test samples, there were also modules installed, and the performance change were measured. And we got those samples after that period, and we did the chemical analysis of dust and the understanding of the adhesion. Yeah, that's what we have done. So optical investigations, microstructural investigation of the soiling, analysis of the chemical composition of the minerals, and also consideration of the dew events. So that's not the result of my shopping at the bazaar for spices here in Qatar. That's dust from different PV modules around the world. So they look quite different just with your naked eyes. But they're also different by a chemical composition. So most of them consist of a substantial amount of quartz, but they also have, in most cases, calcite. And we know from some other investigations that the composition of the dust which is found on the surface of PV modules relates very good with dust which is found on the ground. So therefore, if you know what kind of dust is on the ground, you can also analyze which dust you will have on the modules. This diagram, I will not go into detail, but just to show you, that's from that investigation which showed the different composition of dust around the world. And if you go into literature, in most cases, people using the so-called Arizona dust. It is also standardized by IEEE, also for microelectronic testing. If you're looking how the composition in the MENA regions is, see, it's completely different from the chemical point of view. So it does not make sense to use the dust from the United States to analyze any soiling behavior which will happen here in that area. So therefore, you really have to test samples with the relevant conditions. Yeah, so that is something which we have done. And this is a very easy optical overview of the results from the 9 different locations. You always see the country here, so US is a little bit missing. The period, 1 day, 28 days. Scale is 2 millimeters. It's just an optical microscope. image, and you see it's a dark field one, so you see the change of the soiling. So you see the most severe situation appears in Qatar, but also in Morocco. There are some other countries, like this test in Arizona, it was not so much soiling, but in all those cases there is soiling on the surface. Today I will mainly talk about the two examples which we have investigated in detail in the meantime, which is Qatar and Chile, and at the end I also will briefly talk about Morocco. So if you go to literature and if you talk with people what they believe why particles stick on a glass surface, you quite often find ideas like that. You have a particle which is partially soluble. If you have a DO event, then parts of the particle will be liquid, and then this will dry again, and then you will have an interaction between the particle and the surface, and this will go on, and then you have something which they call the cementation process. I will show you later on this is not true for the situations which we have investigated, so we really have to look into the details. So let's start with Qatar, because this is probably the quite fascinating one. So this is a scanning electron microscope overview of a sample after 1 day, and you see obviously there are particles. If you move into those particles, you see, oh, that's not big particles, they're quite small. They are in the area 10-20 micrometers, but there are a lot of those particles at the surface. If you see those particles here and you see those areas, you see that in addition to particles, there is also something which looks like needles. And if you will magnify that again, so this is this area here, then you will see there is, in addition to the particles, something like a needle structure at the surface. And again, if you analyze that in details, those needles pretty small, they are just 1 or 2 micrometers long, they have a diameter of 50 nanometers. And this was just, the first images were just from a sample which were exposed for 1 day in the environment. This is an example from a sample which was exposed for 28 days. And you see the entire surface is covered with particles and needles. So the question is, what are those needles and how they correlate to, and how they are related to the sticking. So what we did is, we choose that particle, for instance, and then we did a focused ion beam cross-section analysis. So that's the particle, we crossed that, we cut that particle with an ion beam directly at that position. And what you see afterwards is that's the particle, but the adhesion between the particle really comes from an interaction of the needles from the surface to that particle. And if you start to analyze that composition of those needles, again, the right part is missing of that slide. You see they consist of silicon, oxygen, magnesium, and aluminium. If you do a quantitative analysis, you will figure out that they consist of a mineral which is called pedagorskite, which is a clay mineral, and it is quite common. And also the process, which is described in detail in that paper from a PhD student from us, is described there. And it's the following way. So these fibers, they are not airborne, so they are not flying around. So the minerals are soluted in water, and during the DO events, during day and night, those needles are formed if the module surface is drying during the morning hours, and it's forming those needles. So it's really a process which is a solutable process and takes place every day. So we have the formation of those nanofibers every morning on our PV modules, and those fibers will catch particles and will lead to sticking of those particles at the surface. Let's look at the completely different samples from Chile, from the Atacama Desert, and those investigations were done last year. Again, if you look on the surface, that is a longer period where the module were exposed to the environment, 5 months. But again, if you zoom in, you see the larger particles, and again here you see smaller particles. But if you do higher magnification, we do not find those fibers or needles which we have seen before. That's something like small platelets. They're even quite small, around 1 micron in size, and they also appear on the entire surface of the module in addition to the larger particles, which are 20-40 micrometers in size. So we did the same investigation as I have shown before. We prepared focused ion beam cross-section through such a particle which was sticking at the surface of a module. And what you see here, that we have the particle, and those small platelets, they are really arranged underneath that particle. So they are not formed during that process, but by two events they arrange in gaps between the particle and the surface, and by that process they lead to an increasement of the active adhesion surface, and that leads to increased sticking of this particle. So again, we can do some chemical analysis, so that's a magnification of that area here, and if we do so, then we see that it's an kaolinite material, and this is an airborne one which is flying around in the environment. So if we summarize, that is, I think for the first time, at least to our knowledge, it was a comprehensive investigation of microstructural reasons for adhesion of dust particles on surface, and there's a strong difference as a function of the location. Just a summary: left Qatar with those very small, fine needles from the pediscoarchite. This is a solution precipitation, and the small platelets in Chile. In both cases, this leads to a large sticking of particles, and you can hardly move those particles by wind or rain, and you need a cleaning approach. Yeah. Based on that, there are currently several projects with companies to optimize the anti-adhesion layers, because if you understand the chemical processes, then you can really design a layer which is specific to a certain condition. The bad news for industry is there will be not one anti-sticking layer which will serve all situations around the world. You really have to develop a certain one, and I also believe this is a big chance for scientific community here in that area, because you really have to test those layers in the environment here, and you have to think about chemical ideas how to avoid sticking for specific adhesion processes, and I think that's a good idea if you also look in those things. So that's just a result from Morocco. We have not started with the chemical analysis so far. Again, you see some of needles which probably leads to some enhancement of sticking of particles at the surface. This is something which I hope we can report next year. If you're interested, it's very easy to do those tests. We have a simple test kit which can be applied to volunteers. Yeah. With that, I would like to thank all partners which were involved in that project. We did investigations, but all those partners provided the samples from around the world. And I thank you for your attention.